In this video, we're going to talk about the agent's best response function. We previously spoke about the agent's ISO value curves, and we're going to show now how we can derive the agent's best response function from their ISO value curves. In order to do that, though, we're going to have to try to understand a little bit better about what's going on with the agent's marginal benefits and marginal costs of their decision making. So, as a reminder, there we have the agent's value function, VPQ, and that's equal to their per period utility, U as a function of price and quality, multiplied by the lifetime of the contract, which is 1 divided by the termination probability. So, for any price that Patricia, the principal, offers Armin the agent, Armin can do one of 3 things. Firstly, he can refuse the contract entirely. If he does that, his utility will be equal to his fallback utility, which we have assumed is 0. So in that case, his utility would be 0. Or he can accept the contract, but deliver quality equal to 0, which would result in his contract being terminated with certainty. In which case he gets the utility equal to the price, providing 0 quality, and then he gets value of a price and 0 quality. And he gets that for a single period. Or he can accept the contract and deliver the quality that is asked for in the contract, and that's quality is greater than 0, for an expected number of periods. Or he can accept the contract and deliver some level of quality, Q greater than 0, and receive the utility per period, UPQ, for an expected number of periods, 1 over the termination probability. If he does so, he receives VPQ at the level of quality that he provided. Okay. So if he accepts and decides not to set Q equal to 0, Armin is going to choose his level of quality to maximize his value. So that involves taking VPQ and maximizing that function with respect to Q. So if we look at VPQ here on the side, he's going to take that, differentiate with respect to Q, and set it equal to 0. When he does so, he is going to be maximizing his utility. Okay, so what is that going to look like? Let's think it through a little bit. So he's going to take account of the fact that higher Q will reduce the probability that he gets terminated when he does this. So remember what we saw previously with the ISO value curves. The ISO value curves were backward bending, and that was because over some region, increasing Q increases the probability of continuing the contract, and as a result, he would get the per period utility for a longer number of periods. Okay. So, what does that mean? Armin's best response function, which we also call his incentive compatibility constraint, tells us the level of Q where VPQ is maximized. We call it his incentive compatibility constraint because it tells us for which levels of P, the incentive, he will provide a certain level of Q. Right? So P here is the incentive to get Armin to provide a certain level of Q. Hence, his best response function is his incentive compatibility constraint. So that's just to answer this question about Armin's best response function being the constraint on the principal's maximization problem. So we just said that that's what gets us the incentive compatibility constraint, right? That Armin's best response is what gives us the ICC, the incentive compatibility constraint. But in this case, we talk about the best response function being the incentive compatibility constraint for the principal, because the principal is also going to go through a maximization process to try and maximize their profit. And we'll see exactly how that works later. So the incentive compatibility constraint, or Armin's best response function, is going to constrain what the principal can do. Okay, so how do we know the values of Q such that Armin maximizes his value, VPQ? Well, what we can do there is we can see that Armin will maximize his value by choosing Q such that his first derivative of his utility function with respect to Q is going to be equal to the termination probability, T sub Q, multiplied by the value that he receives from the contract overall. So what's happening here? If we differentiate the function on the side here, VPQ equal to UPQ times 1 over TQ, we take that whole thing and we differentiate it with respect to Q. What happens then is we're going to get the result that we have over here. That U sub Q, the first derivative of the utility function with respect to Q, which is telling us about his the disutility of providing that quality, right, is going to be equal to the lifetime value of the contract, VPQ, multiplied by the termination probability differentiated with respect to Q. Okay, so how does this work and how should we think about this? Well, the equation above tells us that Armin is setting his marginal costs equal to his marginal benefits of providing quality. That's how we should interpret that equation. That equation is arrived at through some algebra, which I'm not showing in this video. You can check in the math note how we get from the value function to this first order condition. But what we want to think about when we're interpreting this derivative is that we've got the marginal cost equal to marginal benefit. And that's what Armin is doing when he is maximizing his value with respect to quality. Okay, so let's think about this a little bit on his ISO value curves. So we've got a new curve added to this graph that we didn't have previously. That is the purple line here. Okay, and that purple line is Armin's best response function or his incentive compatibility constraint. Now the question that we have here is, given a price of 20, why will Armin choose point N rather than points G or F? Notice that point N is on one ISO value function and points G and F are on another. So think about that for a little bit and try to decide why at that price Armin will choose to exert to provide a quality of Q equal to 1/2 at point N given the price P equal to 20. So think about that for yourself for a second and then I'll give you an answer. Okay, having paused and thought about that, what we want to see here is that N, first of all, lies on ISO value curve V4. So that is better for Armin than either of the points G or F on ISO value curve V3. But that then means we have to answer the question, why is point N, where Armin is providing higher quality than at point G, or lower quality than point F, providing him more utility, okay, giving him his best response to what the principal is offering him. So what we can see comparing points G and N is that at G, the quality that he's providing is such that at that price, he could increase the lifetime of the contract by increasing the level of quality that he provides. And he does so at point N. Now then you might say, okay, but he could increase the lifetime of the contract more by going up to point F, right? So that's true. But beyond point N, what is happening is that Armin is further up that line, hitting point F. He is now increasing his disutility from providing quality. And when that happens, he's basically taking away from the value that he receives from the contract. And so when he balances the disutility and the benefits of the increased length of the contract, what he does is he chooses point N. And notice what is happening there at point N is that Armin's ISO value curve is tangent to a given price line. We take the price line, P equal to 20, All right, so at p equal to 20, there is a vertical price line at that point. And then the ISO value curve that is tangent to that price gives us the best response function. We'll see exactly why that's true in a moment or two, but just keep that in mind as we progress. I'm going to leave that question. So there's a second question here, which says, why will Armand choose point E over points G and F? And so we could think about that given the question that I was just, or given the point I was just making for you, right? Think about prices and think about tangencies. Why would Armand then choose point E over points F and G? I'm not going to answer that question. You should be able to answer it yourself now. Okay, so we have Armand's value function. And then what you have to think about is that Armand is going to choose Q to maximize that function, which can be expressed as VQ equal to 0. So if we differentiate that with respect to Q and we find that, we're going to see, okay, VQ is going to be equal to 0. V sub Q is going to be equal to 0. So that's the derivative of V with respect to Q, and that's equal to 0. Okay, so V sub Q equal to 0 implies that Armand maximizes VPQ such that U sub Q equals T sub Q times V. So we saw that a couple slides back, right? And what that is telling us is that his marginal utility of Q is equal to the reduction in the termination probability from increasing Q multiplied by his enforcement rent. So what we're going to see here is that he's going to have a value of the contract, VPQ, which is going to give us an enforcement rent from his interaction with the principal. Remember that we saw the enforcement rent, VPQ, is basically that value from the contract minus his fallback. We assumed his fallback is 0 for the moment for ease, and that means that VPQ is his enforcement rent from the interaction with the principal. Okay, so what does that mean? If we take these and we do a little bit of algebra, which you can check in the M note, that gives us Armand's best response function, and that's equal to Q as a function of P equal to 1 minus 2 U underbar divided by P. That is why we get the shape of the function that we saw in the previous slides. We'll comment on that again in a moment or two. Okay, so what do we know? Okay, so what we need to do here is to think a little bit about this question. And the question is, why will Armand not accept the contract if the price is less than U underbar, but will accept the contract if the price is between U underbar and 2 underbar? So that's a question you can answer here. So think to yourself, imagine that P is less than U underbar. What should you do there? Well, look at this best response function and see what level of quality Armand would provide if P is less than U underbar. What would happen then? Then think to yourself, what's going to happen if the price is between U and 2 U underbar? See what would happen there as well. Just substitute some values in and play around to see what would happen. I'm not going to give you the answer to that question, but just I want you to practice substituting in some values and seeing what would happen in each case. Okay, so what do we know? We know that Armand is going to maximize his utility where VQ equals 0. Right? He's taking his value function, he's differentiating with respect to Q, setting that equal to 0. Now, what that means is that the slope of the ISO value curve must be vertical, because the slope of that curve is equal to VP over VQ. All right, so When Armin maximizes utility, we know that v sub q equals 0. That's what we had to find, right? We had to find the derivative of the isovalue curve with respect to q, and that's v sub q. When that happens, we can say that the isovalue curves must be vertical at that point. Why do we know that? Well, the slope of the isovalue curves is equal to minus v sub p over v sub q. If that's the case, then when we divide by 0, minus vp over 0, that means that the slope is going to be undefined at that point. That's only going to be happening when the slopes are vertical. Okay, and so that's what we see at points n on the curve. So at point n, at point E, at point D, at each of those points, we have a vertical line tangent to the isovalue curve, and that gives us the best response function. Remember, the best response function is telling us that Armin is optimizing, and at every point at which Armin is optimizing, it must be the case that v sub q equals 0. Hence our best response function. What we'll see next is that Armin's best response function is going to help us understand what the principal will do once we have seen what the principal's maximization process is going to look like. So we're going to proceed in a few steps. We're first going to try to understand what the principal's choices look like, and then we're going to combine what the principal does with what the agent does, and we're going to put them together. And that'll give us the Nash equilibrium of the incomplete contract principal-agent relationship.